Би жаргал сайхан байна. Та юу чадхаа, юу байгаагаараа, хаа байгаа газараа хичээнгүүлэн хий. Сайн байцгаана уу хүн үзэгчдээ. Өнөөдөр ороо манай дефакто нэвтрүүлгийн зочноор профессор Томас Кабергер, Японы Сэргээгдэх Эрчим хүчний Сангийн дарга оролцож байна.
Томас Кабергер, Японы Сэргээгдэх Эрчим хүчний Сангийн удирдах зөвлөлийн дарга. Шведийн Чалмерс технологийн их сургууль инженери физик сэдвээр мастер, физикийн нөөцийн онол сэдвээр докторийн зэрэг хамгаалсан. Лонд их сургууль, Чалмерс их сургуульд багшилдаг. Хятадын Жэйжан их сургуульд био эрчим хүчний технологийн чиглэлээр зочин экспертээр ажилладаг. Шведийн цахилгаан эрчим хүчний зах зээлийг зохицуулдаг хууль дүрмийг боловсруулахад оролцож байсан. 2008-аас 2011 оны хооронд Шведийн үндэсний эрчим хүчний агентлагийн ерөнхий захирлаар ажиллаж байсан.
Good evening. Welcome to the show.
Good evening. Thank you.
So we have been doing this renewable energy conference in Mongolia. Please tell us about the conference. What was your impression and why this conference was held here?
I think the conference was held here because Mongolia has discovered that the development of renewable energy technologies, in particular wind and solar, has made the Mongolian resources valuable. You have the potential to produce a lot of electricity with solar and wind energy. And now when it's become profitable and the Mongolian economy is growing and the need for electricity is increasing, this is an opportunity for the country.
Some people say that Mongolia could be richer than Saudi Arabia, and it is one of the most wealthiest in the sense of sources of wind and solar. Please let's a little bit elaborate for our audience, what does that mean?
Well, if you go back 10 years, solar and wind energy technologies were quite expensive. There were other ways of providing modern energy that was cheaper and more competitive. But now solar and wind energy is growing all over the world, and the resources here, the land available with a lot of wind and a lot of solar, are significant. They're more than enough for Mongolia's needs, and Mongolia could become a country that exported renewable electricity also to neighboring countries.
We talk about, you said about the cost is becoming lower.
Yes.
And compared with coal power, what was before the cost, which was higher, and what is the cost is today about, technology-wise?
Yeah. If you go back a few years, coal was cheaper when environmental concerns made many countries in the world apply strict regulation on emissions with local health effects, but also on carbon dioxide. Then suddenly wind and solar became more interesting. Today, the development of the technologies to utilize wind and solar has developed so quickly that now you don't even need to have very high taxes on fossil fuels to make wind and solar competitive. They can compete just with the construction cost of new coal-fired power stations and the cost of establishing new mines.
So it's almost the same as a coal energy?
Yes.
We talk about 10 to 11 cents per kilowatt or what?
Yeah, it depends how you calculate investment cost and what resources you have. But as has been shown during the conference, Mongolia has a lot of sun and wind available, so cost here should be competitive.
And yet we have today a lack of electric energy to every household. We have several administrative provinces, small units, where we don't have electricity line coming in. And hopefully, how long it will take a time for Mongolians to be, you think, about self-sufficient with the solar energy if we have so much of the solar and power and wind energy?
I think there will be different kinds of development. We can also see now that energy efficiency for lighting, TV sets, computer, mobile phones have developed, and there are opportunities today to use these household needs based on solar panels and batteries. So such a development could be rather fast, but then building infrastructure to connect all parts of a country to the electricity grid, that will take many years, maybe decades.
I mean, you are scientist, professor from Sweden. How come you are working for a Japanese foundation in Tokyo?
Well, I was working as a Director General of the Swedish National Energy Agency for several years, and we were quite successful in reaching the targets set up in Sweden for increasing the share of renewable energy. And then when I was considering finding another job, I was having a meeting with a Japanese friend who was telling me about this foundation being established in Japan after the Fukushima nuclear accident. And it was obvious to me that the challenge of increasing renewables in Japan quickly to substitute the nuclear power that many in Japan don't want to rely on anymore was a major challenge. It was difficult and important, and therefore I thought fun.
Okay. Before going to Japan, in the case, it's a particular case after Fukushima, you have been working with the National Swedish Energy Agency, and you have been also an energy commissioner.
Well, I've been a member of a temporary Swedish Energy Commission that was appointed in the mid-1990s before the re-regulation and introduction of competition on the Swedish electricity market.
You don't have any more that commission?
No, it was temporary. It was for a couple of years.
Okay, how many members were there, and what was the main?
Well, it was a commission made up of dozen or so. I don't remember exactly the number of members. It was fairly large, and the main task was to look at the energy and environmental targets for Sweden, but also to make the final adjustment to the proposed legislation to introduce competition in the electricity market. In Northern Europe, we now have a common electricity market between Sweden, Denmark, Norway and Finland, and in these countries we have a government grid company, government grid companies that operate the grid, but then there are competing power companies competing of supplying electricity at lowest possible cost or price to the consumers.
So the consumers are receiving from the same grid two different sources, or?
Yes, you use the same grid, but there is competition between producers, so customers can choose who to buy electricity from. So
you touched very important and very actual topic for Mongolians. So how come it can be yet altogether they are connected and yet they are competing?
Right.
Source. Please tell us, how does it work?
Well, an electricity grid must work so that the production and the consumption is balanced at any time.
Yeah, okay.
So one producer may offer to satisfy the demand of one customer, and then he must promise that he will produce the same amount as his customers take out of the grid. And that is controlled and measured.
Okay.
And as
but
long as
the customer doesn't know from whom he is receiving that because it's a general grid.
It's a general grid, so it's just a matter of balancing what is consumed and what is produced. And where you feed in the electricity has little influence. It's just a matter of keeping the balance.
So what you mean is, you have a free price for power?
Yes.
And at which level is this now?
Well, it's I think today at something like 30 euros per megawatt hour on the spot market.
Then I mean competition, and before it was regulated, the price was subsidized or what?
No, there was a situation where each consumer had to buy from the grid owner in the region where you had your house or your factory or whatever.
You had no choice.
So you had no choice, and that changed in the mid-1990s.
And did it boost the industrial output or competitiveness of the country?
Well, what happened initially was that prices dropped dramatically because there was overcapacity. But after 5-6 years, we started a period when electricity prices rose, and as a result, there were new investments in new electricity generating capacity.
New sources.
And now there is once again a period with rather low prices.
What is the structure of source in terms of in terms of
source of energy
solar.
sources? Yeah. We have in Northern Europe a lot of hydropower in Sweden and Norway. There is nuclear power also in Sweden and Finland. In Denmark there is a lot of wind power and coal power. So the countries were quite different initially. Now what has happened in Sweden over the last few years is that we have closed 2 nuclear reactors, and we have increased the use of biomass for power generation, and also in the last couple of years wind power has increased dramatically.
You said you have closed nuclear one in Sweden?
Yes, 2 nuclear reactors were closed. One in the mid-1990s and one in 2005 or something like that.
Why you would close it? There was no, I mean, safe distance, that was okay. We didn't hear anything bad about your nuclear.
No, but these were old, quite small reactors, and they were located very close to the 3rd largest city in Sweden and also the Danish capital, Copenhagen.
I see.
So they were considered...
green movement, Greenpeace, very active in your area.
Well, I think there were also quite significant economic arguments involved.
I see. When you said they're closed, what do you do with the remaining of the nuclear source, whatever?
Well, the spent nuclear fuel and the other radioactive waste issues are still not permanently solved as one of the continued
remaining there, or how does it work?
They haven't started tearing down the reactors. They are just standing there because it's costly to take them down because of all the radioactive waste.
So keeping in that way as it was is okay?
I don't think anyone thinks it's okay in the long term, but no one has a solution that is low cost and therefore immediate. So it's an unresolved
That's
problem.
the concern of Japanese now today after Fukushima. Now, what is the situation in Fukushima now? They have closed completely. What happened now?
The reactors at Fukushima Daiichi, the 4 reactors, they have been announced as permanently closed, and they will have a lot of problems for decades trying to decontaminate and handle the radioactivity in those plants.
Because it was closed, open.
Oh yes, it was destroyed. But then in Japan, all other nuclear reactors are also stopped at the moment. But it's not clear for how long, if some will reopen or not. But there is a strong ambition amongst many in Japan at all levels to try to replace the nuclear capacity with other electricity generating sources as soon as possible. And
because the lag of Japan is one of the largest consumer, the 2nd largest economy in the world, not excluding China, and then they completely cut down 50% of source.
No, the nuclear was almost a third, not quite a third, but almost a third. So
about
it's still
35% shut down, and then how they're surviving now with this lack of energy?
They have managed to reduce electricity consumption, and they've also managed to produce more electricity than usual using, in particular, natural gas.
Okay.
And then, of course, there is a bit of new renewable energy provided as well, but the investments have been slow over this first year. But now there is a system going to be introduced in the middle of this year for feed-in tariffs, so that new investors get access to the grid.
Investors in Japan or outside of Japan?
Anyone can invest in Japan, and so far Japan is not connected to neighboring countries. The electricity grid in Japan is just for Japan. So
this is the island of electricity.
Yes. Okay. And with my European experience, I see that Japan has enormous opportunities to make the electricity system more efficient.
Okay.
They have had Asia's highest electricity prices already before Fukushima. They would benefit if they opened the electricity system so that new investors could come in and provide new sources of electricity and compete with the existing producers to reduce prices.
Competition?
I think there are many in Japan, in the Japanese industry and in political circles, who understand that in the longer term it's important to sort of get the electricity system more vital by introducing competition to reduce costs.
And that's why they pay more attention to the renewable energy, not only inside but outside, right?
Yes.
And the foundation will do the both, inside, outside?
Well, we will encourage renewables wherever available at low cost and as efficiently as possible.
Okay.
And one of the ideas that we are discussing and developing in order to create competition and reduce costs to the Japanese consumers is to connect the Japanese electricity system to neighboring countries.
Korea, China?
Korea, China, maybe Russia.
How about Russia? What kind of talks are keep going now?
Well, I think Russia might be the not the first, but maybe the last of the three. The simplest and most obviously economically beneficial connection would be to Korea. It's not far. There are very large potentials to build wind power plants on the islands and along that cable. So you could use the cable both to make these wind resources available and to connect the two electricity systems.
And the same is also in terms of potential, in terms of consumption at the current level. China is, right?
Yes, China is a little further away. China has on its east coast a lot of the consumption. But still connecting these three countries would mean that electricity supply would be more reliable, more stable, prices and costs lower, so it would be advantageous as well. But I don't think that the Chinese are working very hard to connect Eastern and Western China at the moment. So
and also I understood that for the last 5 years there's a dramatic development of renewable energy power installed capacity-wise, and China is the leading figure.
Yes, China has in a short period, just a few years, become the major investor and also producer of solar PV panels and wind power plants.
What is the total capacity, if you know, in China?
The wind power capacity in China now is just above 40 gigawatt, I think, which makes them the largest wind power country in the world. They have passed the United States.
Even
coming from almost nowhere just 5 years ago, they rapidly invested and become the leader.
Though it is not always return on investment is so much great compared to other sources, China keep increasing this capacity. Why?
Well, I think in China in particular, they are interested in solutions that make long-term economic growth possible. And I think in China it's easy to realize that if the Chinese will continue with their economic development, they will increase their need and demand for energy. And if they would rely on increased use of fossil fuels, they will drive up the world market prices for all fossil fuels, which will give negative feedback on their own economic development.
Because it's such a huge market.
Yes, because they're so large in the world today. And then also, of course, the environmental concerns and the climate change risks are also important to the Chinese. They have
which is not the concern for renewable energy.
No, with renewables you don't have these problems.
You know, technology-wise, could you explain to our audience, with a huge wind farm, wind propeller moves around, does it make big noise?
Well, the early wind power plants that were built were very noisy, and there were wind power plants that you could hear tens of kilometers away even, so they were really nasty from a noise point of view. Modern wind power plants are also, you can hear them, maybe a few hundred meters away, you do hear them. Then it depends on what kind of weather conditions there are, but often there are other noises that are more important.
When you have so many of them, will it have some sort of making dry the area or this sort of effect?
No, you can have local effects like the wind power plants actually taking energy from the wind, so the wind is somewhat decreased. You can have some very local effects like that, but none of the irreversible long-term effects of fossil fuels or nuclear power.
There was some concern, I think, in Latin America, where the birds were flying to north and south. Is the concern real? Or?
Yes, the wind power plants will birds will run into wind power plants and get killed as they fly into buildings and are killed. So there will be birds killed, but compared to traffic or other houses and buildings, it's not an enormous problem. But there are effects as there
could
as
be
well.
accident, but yeah. Well, very interesting. We were talking about hybrid. They making more optimal operation of coal power stations combined with solar or wind.
Yeah.
Please tell us about that.
Well, the presentation we heard today on hybrid systems with solar and coal was a presentation where the idea was that during daytime you can use the heat from the sun to boil water and run turbines. And then when you need electricity also during nighttime, you can use fire coal to heat the same water and drive the same turbines. Wind and solar can also coexist, and the wind turbines produce also during the night, and the solar PVs during the day. But they cannot, none of them can be totally controlled. You can't decide that the sun should shine or that the wind should blow.
That's why you have all this availability, how they say.
Yes, that's one of the important factors. So the hybrid systems can make a system, a standalone system, viable despite using a lot of sun, because you supplement it with using coal.
Do you have this hybrid system in Sweden?
No, in Europe we have very little of that, and the reason is that we have a strong grid. Countries are interconnected, so that electricity can always be transferred from the place where the wind is blowing or the sun is shining to where it's not.
Yes.
So when you have a strong grid, it doesn't matter that much that the production is not.
Well, still it is a good
stable.
Contribution.
It's a very good contribution, because you can always make use of the electricity that the solar PVs or the wind offers, because you can transport it in the grid.
Well, such a huge country. This Mongolia is number 17th largest country in the world, and yet we have so few people, and we are scarce so much.
Right.
And that will be probably from east to west transfer. If we have this major grid, then we can from east to west transfer and vice versa.
Yeah, and I recognize the situation in Sweden in the early 20th century or mid 20th century, when hydropower was being built. The hydropower potential was in northern Sweden, and most of the consumers in southern Sweden. And there are a couple of thousand kilometers in between. And during that development, Swedish industry was very active in developing high voltage transmission lines that reduced losses, and the costs were reduced, and they became important suppliers globally. Now we see similar development in China, where they also have their energy resources in northwestern China and the consumption in southeast. So they're also building new power lines with even lower losses and even more cost efficient, and developing new technologies.
Technology advancement today in this high voltage transmission? What if there's any substantial discovery?
Yes, there are developments of high power electronics that you can actually go from alternating current to direct current. You can do a lot of control of the power grid with new kinds of semiconducting components. There is also development on the material science side, where materials can be made so pure that they can manage to sustain very high voltage differences. So those might be two of the important developments that have made the very high voltage transmission technologies possible, reduced losses, and made them more cost effective.
So is there particular coefficient for particular, say, 1,000 kilometers, that percentage is lost of voltages? Or
yes, it depends a little bit on technologies and so on, but you might lose 5% or so over a couple of thousand kilometers. The losses are not
that big.
Not that terrible. And that's why now when renewable energy potentials are discussed and how to utilize renewable energy, it is shown that you should put the wind power plants where it's really windy, because the difference in wind resources between different places, even if there are 1,000 kilometers apart, is more important than the cost of transmitting the electricity. And that's why this sort of Asian perspective becomes relevant to Mongolia. You wouldn't have thought so 10 years ago, but now it is.
You know, we have another concern in this country because it's a very cold place in winter.
My Swedish experience says that that is how you can do it. We're also a cold country with maybe
Generally
not,
small
maybe not minus 40, but maybe minus 20 in the winter. And all major cities in Sweden have district heating systems. And
centralized heating system.
yes, and we co-generate electricity and heat. So you buy the fuel
From the same source, coal power.
No, in Sweden, which is a country with a lot of forest and forest industries, we use a lot of biomass, and we also use household waste. So when the waste that cannot be recycled and materials cannot be reused, we burn it in boilers where we produce electricity and district heating.
Then you have a concern of pollution, no?
No, the modern technologies to burn, well, first of all, sorting waste so that what ends up to be burnt are the parts of the waste that is suitable to burn. But then also the combustion technologies have developed so the local air pollution is not an issue. You can build these plants near the city centers, and we have them in Stockholm, the capital of Sweden, and in Göteborg, the second
You
largest
don't have
city.
that black smoke we have from
Oh
powers.
no. So with good combustion technology and smokestack cleaning technologies, you can make them. I remember the discussions in Sweden 30 years ago when waste incineration was discussed. There were many of us, I was one of them, who criticized that because of the environmental risk and the waste of materials that could be recycled and so on. And in Sweden, the waste management industry that was often owned by the municipalities, they had a rather intelligent attitude and had a dialogue, and over the years the waste sorting has become extensive in Sweden. So every household do sort waste in different fractions. What can be recycled is recycled. What is toxic, things like heavy metals and batteries and things like that you shouldn't try to burn, they are sorted separately.
Every household sorts themselves before they deliver as a waste.
So that was one important part, and that was done in a good dialogue between the citizens and the waste management companies. And then the technologies to utilize the energy to provide electricity and heat, smokestack condensation, and the cleaning equipment and combustion technologies have been developed in a way where people feel confident that this is done in a proper way. And
that means at a certain level, whole grid can be fit by private companies, sources, etc.
Yeah, that could be possible. You could introduce that kind of market where the grid was controlled by, was a regulated monopoly, and the production and consumption was sorted out on a competitive market.
Well, are you for that centralized, owned by government model, or this competitive model is better?
I think when it comes to the grid, you can't have competition building parallel grids. So I think that is best managed as a regulated monopoly, probably best owned by the
so transmission and distribution network is owned by the government.
Yeah.
Transmission and distribution.
Yeah, transmission owned by the government. Sometimes you might consider having the distribution owned and controlled by municipalities, because it's also interrelated with local city planning. So
And with the efficiency matter too.
Yeah.
Well, this is something I think we still to go through.
Yeah.
You have been working for European industries, including automotive industry, right?
Well, I have been working with energy supply, fuel supply also for the automotive industry, but I was not working for any car manufacturer, but with a company that was involved in developing new alternative fuels for vehicles.
So at which level company would need their own energy supply? Not like in Mongolia we have the diesel when in case of there were a blackout. But at which level of the industry they would need to look for a sustainable source of energy?
You mean if for electricity for production? Well, I think in many parts of the world now there is quite a bit of interest in industry to develop their own electricity supply from sustainable sources, because they think it's important to show that they are responsible parts of society. And we've seen it in Europe, where some companies have decided to have their factories climate neutral, so they're not using any fossil fuels at all. And we see it now in Japan with companies interested in investing in solar PV panels to show that they are trying to help resolve the power shortage after the nuclear reactors were closed. What you can do on a competitive market is that you don't necessarily have to build the electricity production where your factory is. You can build it somewhere else and use the transmission system to get the electricity to your plant. And we see that
except
in Sweden.
heating. You cannot transmit the heating.
Heating is more difficult. You can do it in cities with district heating systems, of course. But I agree. Heating is usually more often local. But we have companies in Sweden who build wind power plants somewhere else in the country and then use that energy for their own electricity for their own consumption.
You have been working. You have been teaching also the Zhejiang University of China, right?
Yes, have been visiting there.
Hangzhou.
Yeah.
And what is that about?
Well, I was invited there as an expert on bioenergy systems, which I have been working with, and I think it's been fascinating over these last 4 years to visit that university and that city and see the rapid development going on and the impressive ability of the researchers to very quickly build laboratory scale conversion plants and develop new technologies. So it's been interesting to compare with Sweden, where we have a longer history of developing bioenergy systems, but a somewhat slower research and decision process than in China.
Hopefully it will happen within this region and with active participation of Mongolia and what you do and the fact you are here and foundations are looking for opportunities. Mongolians are very happy for that, and I wish you good luck.
Thank you.
Thank you for coming to the interview.
Thank you.
Thank you.